Now here is problem number 14. The one-way routes connecting towns A, M, C, X, Y and Z are shown in the figure below, not drawn to scale. The distances in kilometers along each route are marked. Traveling along these routes, what is the shortest distance from A to Z? So for example, if someone takes the route from A to X, X to Y and Y to Z, the total distance would be 5 plus 10 plus 17, which is 15 plus 17 or 32, and we have to find the shortest possible distance. So there's a very neat trick to solve this problem. What we do is simply ignore or cross out the inefficient paths. We cross out the inefficient paths. So let's see what that means. So for example, to go from A to M, there are two possibilities. You could directly go from A to M, which is 8, or you could go from A to X and then to M, which would be 5 plus 2 or 7 kilometers. So this direct path from A to M is inefficient, so we cross this out. Then we look at going from X to Y. Directly it takes 10 kilometers, but via M it is 2 plus 6 or 8. So this path here is inefficient as well, we cross it out. Then to go from M to C, the direct path is 14, but via Y it is 6 plus 5 or 11. So this path is also inefficient. What about Y to Z? So I could go like this, which is 17, or I could go via C, so 5 plus 10, which is 15. So this path is inefficient as well. And then what about M to Z? There is a direct path of 25, but there is also a path via Y and C. So that's 6 plus 5, 11 plus 10, 21. And therefore this path is inefficient as well. So we cross out all the inefficient paths, and now what we are left with is this path from A to X to M to Y to C to Z, and this must be the shortest path. And how long is it? So 5 plus 2, that's 7 plus 6, 13 plus 5, 18 plus 10, that's 28, and therefore A28 is our answer.